All right, so here we go. This is the second module in the cryptography series for TryHackMe. And this one is on John the Ripper, which is a really freaking cool software that allows you to hack passwords, man. It's pretty awesome. If you don't have TryHackMe, make sure you register because it's way more fun to go through these labs together, so that you can actually learn these things while I'm going through it. Unless you just want to sit and watch and learn that way and kind of follow along on your own machine, and you could always do that too. If you don't have TryHackMe, you can get access to it through the link in the description, and you'll get a discount on your membership if you use that link. And yeah, just make sure that you like, subscribe, share, comment, press that little bell button, ring the bell, as they say, so that you can get notified the next time that we drop something about hacking. And this is your boy Hank Hackerson, and of course that's my hacker handle. So I suggest that you have one for yourself too at some point. So here we go. What is John the Ripper? John the who? John the Ripper is one of the most well-known, well-loved, and versatile hash cracking tools that exists. It combines fast cracking speed with extraordinary range of compatible hashes. And so what are hashes? We kind of talked about this in the last room, so I'm not going to spend too much time on it, but they're basically an algorithm, right? And so there's MD4, MD5, SH1, or SHA1, NTLM, and there's a lot. There's a lot more different algorithms for hashes. So as an example, if you take Polo, which is a 4-character word, and run it through an MD5 hash algorithm, you end up with this hash and a standard 32 character for MD5 hash. And if you take Polo Mints, which is 9 characters, and run it through the same hash algorithm, you get another hash that is also 32 characters, but it's a completely different one. And so if you change this to a 0, then this whole thing changes. If you change it to a capital O, that whole thing changes, right? So that's the idea here. So what makes these things secure? Algorithms are designed so that they can operate one way only. This means that a calculated hash can't be reversed through just the output given. So if you put the hash somewhere, unless you use a library like what we did in the last video with CrackStation, or unless you use John the Ripper or all these different things, it's really tough to get the word or the password or something just from the hash. And if you're using a hash for a disk image or a photograph or something, then it's really hard to get the actual photograph if you just have the hash, right? So that's the whole idea. So what makes this, while this is extremely interesting, a mathematical concept that proves fundamental to computing and cryptography, I am in no way qualified to try and explain it in detail here, and neither am I, by the way. But abstractly, it means that the algorithm has that value will be NP and can therefore be calculated reasonably. What? Let me read that again. But abstractly, it means that the algorithm to hash the value will be NP, P versus NP relationship. What does that mean? Let's look that up real quick. So P versus NP is a major unsolved problem in theoretical computer science. In formal terms, okay, I am not reading that. All right, here we go. Whatever. So it's an NP. That's all we need to know. However, unhashing an algorithm would be P and intractable to solve, meaning that it cannot be computed in a reasonable time using standard computers. Fine. So this is where John comes in. Even though the algorithm itself is not feasibly reversible, that doesn't mean that the cracking the hashes is impossible. That's why we have things like John the Ripper. And so if we use something called a dictionary, which there's a lot of free ones on there. One of them is the RockU Wordlist. There's another one called SecLists that it's also available on GitHub, and it has a bunch of different password documents in there. You can do something called a dictionary attack through John the Ripper. And I'm guessing that's what we're going to be doing in this room. So let's move to the next step. So this is just setting up John the Ripper. So if you don't have it on your own machine, you can install it on Parrot Callion the attack box, which comes standard with TryHackMe, which is another really cool thing that I like about TryHackMe, is that there's the attack box that has all of these things pre-installed on it, and you don't need to buy a virtual machine or set up a virtual machine or have a Kali machine of your own, or if you have a weak MacBook, which is actually what I have. I have a MacBook that it's not weak or anything. It's great. I'm not complaining. I should not complain because I have a MacBook, and a lot of people don't even have computers, right? So it's like I'm not complaining about the fact that it's like that, but there's a lot of things that are not compatible with Macs. Let's just say it that way, right? And so if you just have a Kali Linux machine, all of these things come pre-installed on Kali Linux, including John the Ripper. Anyways, so this is the command to install it on Kali or any type of Linux machine. If you're using Black Arch or any other repositories, you may not have John Jumbo installed. To check if you do, use the command this to see if you have it. I'm not going to go too much into that. If you want to build it directly from the source, then you clone the git from GitHub, and then you go to the file, and then you do configure and yada yada yada. So I'm not going to go through all this stuff. You can just pause the screen if you want to read it, and if you want to do it on your own machine through this, and you can just read it yourself that way, right? So what is the most popular extended version of John the Ripper? And I think it was called, was it Jumbo John? That's what it was, Jumbo John. All right, so word lists, here we go. So word lists, as we already mentioned, there is the seclist repository, which is this thing. So there is the discovery word lists, and there's all these things. So if you want to do DNS discovery, it has all these word lists just for DNS discovery. If you wanted to do file system, infrastructure, mainframe, SNMP, all that stuff, right? But then there is passwords. So there's the password word lists, and there's all of these things, including cracked hashes. So there's a cracked hashes password, which is the Millworm password list, and I mean, there's a lot, you guys. There's all of these password lists right here. These are all password lists, and this is all free. If you just go to GitHub and you download seclists, then you get all of these word lists, which is pretty freaking gnarly if you ask me. So there's that, and that actually comes inside our attack box, inside the word list folder in our share folder. And then of course there's the RockU list, and I mean there's a lot of stuff, so we're not going to spend too much time on it. What website was the RockU text word list created from? I think this was from MySpace, right? MySpace.com. Isn't that what it was from? Huh. So let's see if it tells us. For all the tasks in this room, you'll be using RockU, which is a very large common password obtained from a data breach on a website called duh. I thought it was MySpace, honestly, because the last task told us that it was from MySpace. But okay, whatever. All right, so cracking basic hashes. Here we go. So this is our basic syntax. I am now going to open my attack box. I have preloaded it here so that we can have easy access to it. And so this is the syntax. Basically, you use John, and then whatever the option is, and then the path to the file, right? So John invokes the thing. Path to the file would be the file that we're trying to crack, and then the option would be, for example, here word list, and then path to the word list, and then path to the hash file. And pretty simple. So word list, user share, RockU, and then the hash to crack inside a text file, right? So sometimes John won't play nicely with automatically recognizing and loading hashes. That's okay. So you can use the format thing. We're able to use other tools to identify the hash and then set John to a specific format. As it says, there are multiple ways to do this, such as using an online hash to identify it, like this one, which is this thing. It identifies what type of hash algorithm you're using. I like to use called hash identifier. It's a Python tool that is super easy to use, and will tell you different types of hashes the one that you entered is likely to be, giving you more options for if the first one fails. So if you use John for the first time and it can't identify it, then you use this little thing, hash ID, and it'll tell you what it is. To use hash ID, you can just pull the Python file from GitLab using this git and simply launch it with python hashid.py and then enter the hash that you're trying to identify, and it will tell you possible formats. Format specific cracking. So John, format of the hash, word list, path to file. Pretty simple. Example usage is right here. And a note on formats: when you're telling John to use formats, if you're dealing with a standard hash type, example MD5, you have to prefix it with raw to tell John if you're just dealing with a standard hash type, though it doesn't always apply. To check if you need to add the prefix or not, you can list all of John's formats using this thing and either check manually or grep for your hash. So, oh, I could have done this in the last video, which is much, oh man, that's much easier. Okay, very good. Practical. Now you know the syntax. Let's get to work, buddy. Super excited about it. What type of hash is the hash1.txt? Now I wonder if I actually have to download this, and I wonder, let me see if I can find it on here. So cd rooms ls John the Ripper. Is John the Ripper in here? John the Ripper is not in here, so it's not going to be in this thing. So let's see if we can do locate hash1.txt. Golly. Is there something called hash1.txt? There is not. So what type of hash is hash1.txt? So I actually have to download this on my computer? Gosh. First task hashes. Maybe we can find that, huh? Locate first task hashes.zip. Find first task hashes.zip. No such thing. And is there, what's another one? It's which first task hashes.zip. Nope. Okay, I guess I gotta do it through my machine. So let's unlock this real quick. And here's the file. So let's look at it real quick. Hash1. And why I gotta do it like this, bruh? That's why I don't like this. Sometimes I don't like it when they do this. So hopefully you can still see what I'm doing over here. And so this is it. So it gives us 4 hash types. And so we're going to just open this and we're gonna copy this hash, and maybe, do they have hash ID? So what if we can see if we can find that? Locate hash id.py. Find hash id.py. Okay, fine. You don't have it, so I'm just gonna get it. And I'm going to, all right, I gotta recopy the thing after I do this, because we gotta first get this, paste, hash ID, there's hash ID. Now let's go get the hash one more time, copy. Okay, where is hash ID? It's right here, so python 3 hash id.py, and then paste this thing in here. It's MD5, so I'm gonna guess that this is an MD5 hash. Correct. What is the cracked value of hash1.txt? So I'm going to, will it tell me if I put it in here? I don't know. So back, exit. How do I get out of here? Exit like that? Nope. Back like that? Nope. Okay. How do we get out of this thing? Alright, so I guess I'm just gonna close this out. Close it. Let's open another one. And so I already have a hash file, so I'm just gonna do hash1.txt. And I'm gonna paste my hash in here. And we're going to exit out, and we're gonna do John word list equals user share word lists rocku.txt and then hash1.txt. Let's see if we can get that. Okay, I wonder if this is the password. Let's see if this is it. No. What if we put 2 dots at the end? No. Let's do, what was it? Format raw, I think it was. So what was the command? Where was it? Where was it? There was something. Okay, right there it is. So John format equals raw MD5. Word list equals user share word lists rocku.txt hash1.txt. Biscuit. Okay, there you go. Biscuit. Okay, cool. All right, so what type of hash is hash 2? So, like so, we're gonna open this one, copy our hash, go back here, Python 3, and what was it called? Hash ID, right? Hash ID.py, and then paste that. SHA1, most likely, right? That's what it seems to be. So let's try that. SHA1. Okay, that is it. And so now let's put it inside. I need to know how to exit this thing, man. I can't keep recreating it. How do you exit this? What if I just do Control C? There you go. Okay, Control C works. Nano hash2.txt. Paste and exit. Yes, save it. And let's do SHA1 crypt. I think that's what it is, right? So John format SHA1 crypt word list equals user share word lists rocku.txt and hash2.txt. Default encoding. Okay, so what was it? John list formats grep if SHA1. I did do SHA1 crypt, so why did it not work? Using default input encoding is UTF-8, hash2.txt didn't work. And did I do anything incorrect here other than maybe raw SHA1 is what I should have done? That could be it. All right, let's try it. So we're just gonna go up here and we're gonna do, come on, raw SHA1. Oh, capital R, really? Is that the reason? Oh no, I wasn't supposed to even use crypt in there. Okay, so let me just, I'm gonna type it exactly as that thing says, raw SHA1. Hey, there you go. Exactly as it says, so kangaroo. Just like that. All right, so let's, I mean, we're just gonna keep going down the line, right? And by now, hopefully you see kind of what the process is like, right? It's kind of scary how simple it is, right? How simple is it that we could find out? So just by going to hash id.py and pasting the hash, then it tells us SHA 256, right? So SHA 256, and lo and behold, that's what it was. And then we just exit out of this thing, and then we just go to John, and we say format, right? Is that what it was? Format, I'm sorry, list formats. So list formats, come on, formats, and then tell me if I can find SHA 256 in here. And there we do, and I'm guessing it's gonna be this one, because this seems to be the theme where we do raw whatever. So we're just gonna try raw. First I gotta put it inside a text file, and we're gonna do that, and we're gonna make sure we save it, and we are going to do John format equals raw SHA 256. Then you're gonna do wordlist equals user share wordlists raw_q.txt #3.txt. All right, on the first try, we got it this time. Very good. And last but not least, ladies and gentlemen. Ooh, this is a long one. That's what she said. All right, here we go. Python 3 hash ID, and give me the goods. What is this? 512. Okay. Ooh, maybe not, because this seems to be a long thing. So maybe it's Whirlpool. Let's see. Whirlpool. It is Whirlpool, so it's not SHA 512. Okay. So if it's Whirlpool, John, format list, or list format, is that what it was? List formats, is that the, yep, list formats. Okay, list formats, and then grep if Whirlpool. Okay, simple enough. So let's see, John format equals Whirlpool. There's a few variations, so let's just try the first one. Oh, whoops, I gotta actually save the hash real quick. Did I save that? I don't think I did. Nano hash 4. I did not save it. Okay, and so now John format Whirlpool and wordlist equals user share wordlists raw_q.txt #4.txt, just like that. There we go. Last one, colossal. And just like that, we cracked our first hashes. Okay, so let's read through. I didn't need to close that really, but let's see. Okay, Windows hashes, here we go. Now that we've understood the basic syntax of John the Ripper, let's move on to cracking something a little bit more difficult, okay? Something that you may even want to attempt if you're on a real penetration test or red team engagement. Authentication hashes are hashed versions of passwords that are stored by operating systems. It's sometimes possible to crack them using the brute force methods that we're using. To get your hands on these hashes, you must often already be a privileged user. So we will explain some of the hashes that we plan on cracking as well as we attempt them. So NT hash and NTLM, these are the stuff for Windows. Let me actually do this because it's kind of easier to zoom in so that you could see it. Okay, here we go. So NT hash is the hash format that modern Windows OS machines will store and service passwords in. It's commonly referred to as NTLM, which references the previous version for LM, thus NTLM. A little bit of history, don't really need to. NT, I guess, for new technology and was used with Windows NT, MS-DOS operating system. Eventually, the NT line became the standard operating system to be released by Microsoft. You can acquire NTLM hashes by dumping SAM database on a Windows machine by using a tool like Mimikatz or from the Active Directory database NTSDIT. You may not have to crack the hash to continue privilege escalation, as you can always conduct a pass the hash attack instead. By sometimes, hash cracking is a viable option if there is a weak password policy. Okay. Now that you know the theory behind it, see if you can use the techniques we practiced in the last task and the knowledge of what type of hash this is to crack the NTLM text file. Okay. So what do we need to set the format flag to in order to crack this? Okay. Let's zoom out and let's see what we can find here. List formats grep if NTLM. Is a 2-letter answer. So what would be the two? NT maybe? I think NT is the word. Okay, NT is the right one. All right, so what is the cracked value of this password? Let's download the task file real quick. And it's just a basic TXT file right here. And that is our hash. So we're gonna go here. It's so much easier if it was just available inside the machine. Gosh darn it. What am I doing? I am doing nano hash. I'll just do NTLM to keep it simple. Okay, and here we go. John format equals NT, and then we're going to do word list equals user share word lists rocku.txt and ntlm.txt. Mushroom, baby. Let's get some mushrooms. Hey, moving on. Making some progress here. So from etc shadow, this is something that is on Linux machines, unshadowing. So you gotta unshadow first. It's very particular about the formats that it needs data to be able to work with. For this reason, in order to crack etc shadow passwords, you must combine it with the shadow password file, or the etc password file, in order for John to understand that the data is being given. To do this, we use a tool built into the John suite of tools called Unshadow. Basic syntax of Unshadow is this: Unshadow, path to the password, path to the shadow. So that means path to this thing and path to this thing. Okay? And then Unshadow invokes this. This is the file that contains the copy of this and the copy of that copy of this. Unshadow, local password, local shadow, and it goes into the unshadowed txt. So you gotta do this part to gives you the unshadowed part. When using Unshadow, you can either use the entire etc password and file, or if you have them available, or you can use relevant line from each example. So file 1, local password, file 2, local shadow, basically. And it kind of looks like this. So this would be root, which is the line 1 from the etc password file. And then this would be the hash from the etc shadow file for root. And as we learned from the last one, this is the, if it starts with this is SHA 512. Okay, so cracking. Then you crack-a-lack it like this. So word list, rocku, format, SHA 512 crypt, and then the unshadowed text file. Okay, so is this a downloadable thing? Yeah. etc hashes.txt. Okay, I just gotta do the same thing, right? So go here, etc hashes.txt. This is everything I managed to recover from the target machine. So we have the root, and then we have the root right here. So I'm gonna copy this one, and that's gonna be our, this is gonna be our etc password. So nano etc password. Oh, whoops. Okay. So this is the actual one inside our machine, so we're not going to use this one. So we'll just do nano password. How about that? Okay, cool. That's empty. And I'll just paste it in here, and that's what we got for this one, right? This is for the local password. I just want to make sure I'm doing it right. Yeah, okay, so that's cool. and we're going to do nano shadow. Okay, that's also empty, and that'll be this thing. Oh wait, I gotta actually take the whole thing. So I'm gonna take this whole thing, copy, and we're gonna paste it in here, X that out. Okay, and so what is the command to unshadow? The unshadow is unshadow password and shadow. Should it have been a txt file? Let's see. Well, we're gonna find out right now. Unshadowed.txt. Let's see if that works. And nano unshadowed.txt. Oh, it did work. Okay. All right. Seems like it worked. Let's see if this actually is going to do our hack for us, our little crack for us. And we want to get used to typing these things out. So that's why I'm doing it instead of copy pasting. It's good for you to learn how to type these things out so that you can actually learn the commands. SHA 512 crypt unshadowed txt. And it worked. And how simple is that password? My God. Just like that. Okay. Simple enough. Easy enough. Single crack mode. Let's go. So far we've been using the word list mode and not the simple hashes or word list mode with not so simple hashes. And then there's something called single crack mode. Which is if we take the username Marcus, some possible passwords could be these things, right? So 1, 2, 3 at the end, or changing some of the letters inside it, or adding something weird at the end. It's called word mangling. John is building its own dictionary based on the information that has been fed and uses a set of rules called mangling rules, which define how to mutate the word it started with to generate a word list based off of the relevant factors. So geckos. Implementation of word mangling also features compatibility with the geckos field of the Unix operating system and another Unix-like operating system such as Linux. So what are geckos? Remember the last task where we were looking at the entire entries of both these two files? Well, if you look closely, you can see that each field is separated by a colon. Each one of the fields that these records are split into are called gecko fields. John can take information stored in those records, such as a full name, home directory, and add it to the word list it generates when cracking etc hashes with a single crack mode. So using single crack mode, we use roughly the same syntax that we used before. For example, we wanted to crack the password of the username Mike. Using single mode, we use John, single, the format is going to be whatever the format is, and the path to the file. Single lets us know that we want to use the single hash cracking mode. So single format raw SSH 256 and the hashes inside the text file. Note on file formats in single crack mode. If you're cracking hashes in single crack mode, you need to change the file format that you're feeding to John for it to understand what data to create a password list from. You do this by prepending the hash with the username that the hash belongs to. So according to the above example, we would do this to the file. So it goes from this to Mike, colon, and then the hash at the end of it. So practical. So assuming that what the user belongs to is named Joker. So let's go and get this little task file, which is hash 7. And hash 7 is here. And so we're gonna use copy here. We're gonna go here. We're gonna do nano hash 7 .txt. Then we're going to do Joker at the start of it, and we're going to paste the hash, and this is going to be our single crack mode. And so simple enough. Do we know what it is? I think we should find out, right? So we already have this tool, why not use it? So hash id.py, and I'm going to paste the hash in here. Let's make sure. MD5, I see. It seems to be that it's an MD5 hash. Okay, so if that's the case, let's use MD5. And it was, what was it? Oh, actually, I don't think it even matters. Oh no, it does matter because we're using format inside this thing. Okay, so MD5, what was it? I think it was raw. Okay, let's do one more time. So John list formats IF MD5. Wasn't it IF? What was the thing to find out what it was? I think it was, right? Wasn't it IF? I thought it was. It is IF. Oh, grep IF. I totally missed the grep IF part. List formats grep IF MD5. Okay, there you go. And it is, I think it's raw, this thing. I think that's what we're supposed to use. So we're gonna do, what was it? It was John single, right? Format is raw MD5, right? MD5. And then it was hash 7.txt, I think. Hey, there it is. We got it. Simple enough. So Joker, like that, right? Nice. Cool. Moving on. So custom rules. So as we journeyed of what John can do in single crack mode, you may have some ideas about what some good mangling patterns would be, or what patterns your passwords often use that could be replicated with a certain mangling pattern. You can define your own set of rules is the good news. So let us see here. Common custom rules. Polo password. Okay. Capital letter, number, symbol, which would end up being Polo password with a capital P at the beginning and an exclamation at the end. Password with a capital letter first and a number followed by a symbol at the end. Very good. This pattern, familiar password appended by da 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 da, is a memorable pattern that people will use and reuse when they create passwords. That's great. Now, this does meet the password complexity requirements because they're supposed to use a number and a special character. But as an attacker, we can exploit the fact that we know likely position of these added elements because we're bad mofos. So custom rules are defined in the configure file, usually located in this folder if you've installed John using package manager. So it is in this folder on our attack box. So let's go over the syntax of these custom rules using the example above as our target pattern. Know that there is a massive level of granular control that you can define in these rules. I would suggest taking a look at the wiki here in order to get a full view of the types of modifiers you can use, as well as more examples of rule implementation. The first line, list rules, THM rules, is used to define the name of your rule. This is what you will use to call your custom rule as a John argument. When we use a regex style, regex, I think, regular expressions, not regex, regular expression styles, pattern match to define where in the word will be modified. Again, we will only cover the basic and most common modifiers. AZ takes the word and appends it with the characters you define. A0 takes the word and prepends it with the character you define. C capitalizes the character positionally. This can be used in combination to define where and what in the word you want to modify it. Lastly, we need to define what characters should be appended, prepended, or otherwise included. We do this by adding character sets in the square brackets. In order they should be used, these directly follow the modifier patterns inside the double quotes. Here are some common examples. 0 to 9, and I mean, I'm not going to go through reading all this stuff, but it's basically what the rules are here. So putting this all together, in order to generate a word list from the rules that would match the example password of this, we would create a rule that entry that looks like this. So list rules polo password, and then C, AZ, 0 to 9, and the special characters. In order, meaning capitalize the first letter. So C stands for capitalize, right? Append to the end of the word, and then a number in the range of 0 to 9, followed by a symbol that is one of these things, right? So let me just kind of ingrain this. Well, we'll do some trial and error, see what we can find. So we could then call this custom rule as a John argument using rule polo password flag as a full command John word list path to word list, rule polo password, and path to the file. As a note, I find it helpful to talk out the patterns if you're writing a rule as shown above. The same applies to writing regex patterns too. Jumbo John already comes with a large list of custom rules which contain modifiers for use for almost all cases. If you get stuck, try looking at the rules. It's around line 78 if your syntax isn't working properly. Now time for you to have a go. Holy crap. Okay, so what do custom rules allow us to exploit? Let's first find out the answer to this thing. I'm going to zoom out a little bit just to remind myself. Custom rules, this is good. However, we can exploit the fact that most users will be predictable in the location of these symbols for bug criteria. Okay. The password complexity requirements. Maybe that's the answer. Let's see. Password complexity requirements. Nope. Password complexity predictability. Okay, I was close. What rule would we use to add all capital letters to the end of the word? And it's right here. Okay, so I believe it's this. AZ, this, AZ, this. Correct. Hey, look at that. What flag would we use to call a custom rule called THM rules? So we would do rule equals THM rules. Okay, fair enough. I guess we didn't have to create the rule and everything. Maybe we'll do that in the next one. Oh, no, we won't. Okay, moving on. Okay, so cracking a password file protected in a zip file. Yes, that's right. We can use it to crack the password on a password protected zip file. This is going to be awesome. Okay, similar to the unshadow tool that we previously used, we can be using the zip to John tool to convert the zip file into a hash format that John is able to understand and hopefully crack. The basic usage is zip to John, the option, zip file, and then the output file. The option allows you to pass specific checksum options to zip to John. This shouldn't often be necessary. The path to the zip file. This is the output director, and then the output file that we want to store the output. So example is this. Cracking would be rocku, and then using the zip hash.txt. Okay, so I emailed myself the zip file. I'm pretty sure there was a different way to do this, but okay, there it is. So it's inside our actual directory that we're in right now. Okay, so let's continue on with this. So what is the option here? So it's zip to John, and this shouldn't often be necessary. Okay, so maybe we can skip that part. And so okay, so let's see, zip to John secure.zip, and the output file would be zip hash.txt. Okay, I guess it worked. So let's see. It worked. Okay, so now let's try to unzip the file. And we were able to, and there is the, oh, there it is. Okay. And there's our flag. Okay. There you go. Fun stuff. This is pretty cool, man. John the Ripper is pretty badass. I mean, if you guys don't think so, I don't know what to tell you. All right, so here we go. Cracking a password protected RAR drive. Nice. So it's RAR to John, RAR file, output file. RAR to John invokes the RAR to John tool, the path to the RAR file, then the output file. So this is what it's going to look like. And then you would crack it in the same way. So same thing. What is the password for the secure RAR file? So let's get the file. Okay, unfortunately, my email does not allow me to send RAR files, and it blocked it automatically as an attachment. So I kind of did the sneak around for this and got the password by looking at some forums and things like that. And I mean, the process is very much the same as what we did for the zip2 file, so the John unzip thing. And I don't have John installed on my local computer. Otherwise, I would have just done this on my local computer. But this is basically the process. And so I'm pretty sure if you just follow the instructions, it'll happen exactly as is. And we can make sure that we got the correct flags and everything. So that was the RAR archives, and we can now move on to the last section of SSH key passwords, which is a pretty important one, I think. So no more file archives, fine. Let's explore one more use of John that comes up semi-frequently in CTF challenges, using John to crack SSH private key password of ID RSA files. So we used this in one of the previous videos where we were just using the ID RSA file to actually log into somebody's SSH or SSH into a machine using that. But how can we actually get the password out of that? And lo and behold, wouldn't you know it, there's something called SSH to John. So with the Python opt SSH to John .py, or on Kali, Python user shared John SSH to John pile, so on and so forth. And so you would use this command with the key file, and then you would get the output file. The SSH to John invokes the John tool. IDRSA private key file is the path to the IDRSA file, and this is our output. So this would be the example command, and then you would crack it pretty much the same way, right? So let's crack the hash of the ID RSA file to this task. Here we go. All right, there's our ID RSA file right there. So let's just run the command and see what we can find here. So got it. Okay. All right, here we go. 5th time is a charm. Root tools. And let's go put a quote at the beginning of this. Password attacks. John SSH2 John.py and IDRSA.IDRSA, and you're gonna export to this file. I think that worked, you guys. Nano IDRSA.txt. Hey, we actually got it. My gosh, that took so many freaking tries, dude. You guys didn't see it because I edited it out, but that was freaking gnarly. Okay, so now here we go. My God, man. That was, golly, that was crazy. And IDRSA, no, IDRSA.txt. Look at that. We got our password. And there it is. Mother effer. And there we go. Okay, we got it. And so last thing, further reading. Thank you for completing this room on John the Ripper. I hope you learned along blah, 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 blah. And I recommend checking out the OpenWall wiki for more information about using John and advice, updates, or news about the tool. And we have completed this long ass room, but it was very freaking insightful. So I definitely liked it. I learned a lot about John the Ripper. I feel much closer to being a hacker, to be honest with you, because this was freaking badass. And I'm pretty sure by the end of this video, you learned a lot too, and you became closer to being a hacker too. So this is your boy Hank Hackerson, and I hope you liked the video. Make sure you like, subscribe, share, comment, hit that bell button so that you get more videos the next time we drop them. And there is actually one more module in this whole hash cracking module with TryHackMe. So there's definitely going to be another video on this, which is actually right here, the encryption crypto 101. So this is the next video that we're going to make, but it's obviously going to be a different video because this video was way too long and I gotta make sure I cut it. So yeah, that's it. If you don't have TryHackMe, you can get it through the link in the description. You'll get a discount on your membership and you can use all these badass rooms for yourself, or if you could just, if you want, download these things on your own computer and follow along using these videos so that you can learn how to hack ethically, you know. This is a felony if you do it without permission, so just make sure that you actually, if you're gonna do it against somebody, make sure you have their permission. Otherwise, do it against your own machines. Otherwise, just know that it is a felony and you will get in a lot of trouble if you do this without permission. So that being said, ladies and gentlemen, I will see you in the next video. Peace, love, and chicken grease. Talk to you soon.